and has received many awards for his outstanding contributions to the profession. He has written dozens of articles and 12 books. Peter is experienced with more than 500 data management practices in 20 countries and consistently named as a top data management expert. Some of the most important and largest organizations in the world have sought out his expertise. Peter has spent multi-year immersions with groups as diverse as the U.S. Department of Defense, Deutsche Bank, Nokia, Wells Fargo, the Commonwealth of Virginia, and Walmart. And with that, let me turn it over to Peter to get his presentation started. Peter, hello and welcome.
Welcome, Shannon, and thank you, Gary, for a great little talk on getting us started on this. Shannon, is my music still playing? I had a feeling I might have left that on.
I would have let you know, and we're all good.
Oh, good. All right. Well, welcome, everybody. That's all right. And our feedback crowd will let us know when we make mistakes and all that sort of thing. We welcome absolutely all of that. So welcome. Today's a first time we've tried this topic in this fashion here, and it's really in response to your requests. So do keep in touch with Shannon. Let her know what it is you'd like to hear. Talk about data preparation fundamentals. And it's an interesting topic in that not many people really kind of get this. And I'll tell you through a couple of bits here, but let's start out with a very well-run survey here by Randy Bean and Tom Davenport. And again, you get these slides. You can see the slide, the URL is very straightforward, dovantage.com in there. So get years worth of studies that they've done. And what they've determined over the years is that organizations are not driving innovation with data largely. They're not competing on data and analytics. They're not managing data as a business asset. They're not creating data-driven organizations, and they're not creating data cultures. Now, those are interesting stats. They are actually current as of last year, so wonderful pieces. Here's another piece in the upper corner, though. You'll notice that when asked, organizations responded that the problems that they have around data are largely people and process based. They are not technology challenges. So technology needs to play an important role, but it can't play an all-consuming role in what you're looking into. Let's take a look at how this actually works out from an external perspective. Start to say that we're going to have to do some amount of data analysis and some amount of preparation in order to get ready for the data analysis. And what do I mean by preparation? Well, it's any action. Typically, it's defined as munging, M-U-N-G-I-N-G. You can look it up at Wikipedia, but it's a non-destructive act of improving the data in one area. So this is probably not optimal. In fact, maybe an optimal solution would look like this, that you could spend 80% of your expensive data analysis resources, your data scientists, et cetera, 80% of their time doing analysis and 20% of their time doing preparation. And if you had that ratio, you'd do everything you could to take that 20% down to zero. Of course, it doesn't work that way. And worse still, if you're just finding out, everybody else knows that data munging occupies 80%, data preparation occupies 80% of the time devoted to data projects around this. And when I say everybody knows, it's because if you talk to anybody in the business, they will tell you 100% of the time. There's good scientific data backing this up as well, but this is really quite common knowledge inside of the data community, outside of the data community, when you're planning these things, when you're trying to recruit people, or you're trying to manage a project of this type, it is very much problematic. And what these Pareto data realities add up to is that 80% of your data is redundant, trivial, or obsolete. 80% of your data is of unknown quality, and 80% of your data is what I call standards free, which means 80% of your highly paid analytic capabilities spend their time working under these conditions. This is a problem because IT has always considered data a business problem, whereas the business looks around and sees somebody with the title of Chief Information Officer and says, who else would be taking care of my data? Data has fallen into an enormous chasm between business and IT, and it's up to us as data professionals to put it back together, reestablish the trust and cooperation. But we have to do that in spite of mountains and mountains of data debt that slows progress, decreases quality, increases costs, and presents greater risks. And data debt is the idea of just getting to a normal state, getting back to zero. Generally, it involves undoing existing stuff with a new set of skills that you may or may not have organizationally. And this leads to a real challenge around the idea that large numbers of businesses report making bad data decisions or using data to get to bad decisions. In fact, I call it a bad data decisions spiral. Business decision makers and technical decision makers are not data knowledgeable, therefore they make bad data decisions, leading to poor treatment of organizational assets and poor data quality, leading to poor organizational outcomes. Lather, rinse, and repeat. How does one break out of this?
This is wrong.
Morgan Freeman, this is wrong is absolutely correct. The question is, if you don't recognize that this is a problem, you'll never stop making these concentrations. So what I hope I've done is motivate you a little bit to say that data preparation is an unknown but very important component of what we are looking at here. Where we're going to go next is data preparation considerations, talk about why data problems are different, and spend a fair amount of time in an area I call reverse engineering, which is generally the idea of understanding your data sets or introducing yourself to a data set. So let's go into the considerations piece. Data is not broadly or widely understood. It's like the blind persons and the elephant. Somebody thinks it's a fan, a snake, a tree, a rope, a wall. And of course, in the data world, people come in through various paths as well, thinking that's all there is to data, and most do not develop a holistic approach to taking a look at it. Our approaches in the past in terms of definition have not been useful either. We have said that data management is everything that occurs between when data is sourced and when data is used. Well, that's useful, but not very precise. Also correctly true. So first of all, let's look at it from a sources, data management, and uses, but let's take the word uses and replace it with reuse, because if we don't plan to reuse, we will not be able to invest more in our data assets and obtain value from them. So that's a big fundamental change right there for organizations. Here's another refinement of the same topic. The idea is, of course, there is some preparation, and here are some lists of describing them, and then some exploitation components on the other side. Again, we have to put this into the reuse context and understand this is where the 80-20 ratio of it comes from, and that only governance around these topics can actually help us to prevent what has become standard in most organizations. Now, in addition to the not fully understanding the environment and the amount of effort required in each one, many people look at technology as a one-legged stool. That is, it's a be-all, it'll solve all our problems, but of course, if you try to do anything with a one-legged stool, it doesn't work very well. 3 legs being the minimum operative required. And from a data perspective as well, it's also got to be a combination of people, process, and technologies. But even more so than most disciplines, these 3 are interdependent to a very high degree in this environment here. And identifying winning combinations of people, process, and technology groups is what leads you to not approach data management preparation as a series of technologies, but as an architectural problem. And that data technology is part of the overall technology architecture that the organization undoubtedly manages. Again, part of the enterprise data architecture, addressing at least 3 questions. What are the technologies acceptable? What purposes are we applying to which circumstances? And in distributed environments, how do I move data from one place to another? These are requirements that must be understood before you attempt to go out and survey the market and look at various types of organizations and solutions and things. Another good reference around that is the ITEL standard, which is available online and should be examined in the sense that it is a reference model for technology management, and managing data management technology is a part of technology management. So we should inherit all of the good practices and all the discipline from this well-established discipline in it here. They're not real heavy on data in here, but nevertheless, it is technology management, and so should be adhered to precisely as such. See, the idea is, what is this technology doing and how is it providing value for the organization? And I'll show you an example at the end here of diminishing returns. But the idea is understanding these requirements will help confine our solutions to things like, what is the problem this is supposed to solve, and what sets this technology apart from all the others, and are there specific requirements, and does the technology involve data security in any way, shape, or form? All of these are important criteria around this. So the problem is there's no standard audience for this, and they consequently do not understand as well the need for high performance automation, particularly within the data field. And data tends to be a binary thing, that it works or it doesn't work, but there are some in-betweens that happen here as well. And it really involves a combination of the organizational data literacy, its data supply, which is typically uneven, especially at first, and use of standards, as I mentioned before, lightly applied in most organizations. And what we have to do to make this data sandwich is to firm up these ideas, to apply standards and literacy and supply chain analysis where it makes sense to produce a well-oiled machine. And this can't happen without investments in engineering and architecture. And even though it's sort of a sad commentary on the world, I actually traveled to this tea farm in India a couple of years ago, and on the cash register was this wonderful phrase: quality engineering architecture products do not happen accidentally. And of course, we can add the word data to it as well to make sure that everybody understands the investment that is needed in these architectures from a preparation perspective. It's, again, involved in understanding what needs to be done to prepare the data that is needed for later analysis around this. And the reason it's a challenge for most organizations is illustrated best by the story of Galloping Gertie, the former Tacoma Narrows Bridge. Yes, I've given away the result already. It opened on July 1st of 1940 and collapsed on November 7th of 1940. One of the famous failures of bridge building, and they learned a lot of lessons from this. You can imagine the idea, first of all, there's a car that you're looking at. It's not very easy to see on your screens there, and a dog that was running there. And the fellow went back and got his dog out because he realized that the car was probably not going to endure the way this bridge was rotating on this. These are high winds causing harmonic vibrations. And of course, you know, if you take the top of a Coke can and sizzle it back and forth, it will eventually break off, as the bridge is right before our eyes. This is a very dramatic failure. And while data failures cost organizations 20 to 40% of their IT budget, they are, instead of being obvious and overt like this, they are insidious. Tom Redman, a good friend, put together a wonderful term to describe them as hidden data factories. For example, if Department A delivers work to Department B and Department B keeps asking for corrections from Department A but doesn't make them, it makes them for them. That's a hidden data factory that shouldn't have to be done. Actually, the workflow that I just described to you includes B also sending on imperfect work to C, and C sending that imperfect work to customers. 3 additional hidden data factories that are out there where knowledge workers are looking around for stuff, again, and spending 20% of their time doing the work. This is part of the reason why. And these hidden data factories take over many parts of our organization, and we don't see them. And there's another good reason we don't see them as well. These bad data manifests itself as different types of organizational challenges. Think about it. In every case, data is going to be filtered through an IT process, a business system of some sort, in order to do this. And only when you connect the dots and find out that these have some root causes, and that root cause analysis is part of data governance. They have to be forensic detectives in that sense to be able to understand these issues. And only when you put a team together that understands how to use these issues is it a good approach. Imagine each of these individual data challenges that I show on this slide being addressed individually by a local work group and buying a specific tool to fix it. It may or may not work on it, but it's certainly not going to be most effective when we look at it going around. Again, keep on moving here to the sort of meat of this presentation here. What we have is, first of all, a definition of what we teach most young people in university. We teach them that systems are built by describing them as what, how, and then as built. This is the process of forward engineering or just building stuff, also known as big D design. The what components are typically written down in some sort of a written set of specifications. The design components are model-based generally, and the implementation obviously is implementation. These same steps occur whether you're doing this in the cloud or on-prem development. The idea is that there's still got to be thought, and what we do most poorly is think about the requirements aspects of this. It's just a habit we've learned over the years. This is, of course, all we teach young people, but the concept of reverse engineering, which I have to say I had a hand in defining some parts of it for some work that we did at the Defense Department, is a structured technique aimed at recovering rigorous knowledge of the existing system to leverage enhancement efforts. All right. Every system does some stuff well and some stuff poorly. If we don't know what stuff to leave behind and what stuff to bring along, how do we avoid making the same mistakes twice in our redevelopment, our evolution efforts? So the idea of moving from as is to design and design to requirements are two specific components of reverse engineering that have important aspects that are just not usually addressed. Most people discover them. And this is where the tool suites that Gary was describing earlier can become helpful just at the start of this. There's lots of other places as well. Again, the whole environment here is shifting from building new systems to building instead on existing systems or migrating existing systems to certain places. So we can't call the process re-engineering unless we first understand the existing system's strengths and weaknesses. We may need to bring them all the way back to the requirements, the what, but we oftentimes can get away with just going to the how in order to do this. But if we don't use this information to inform the design of the new system, we are not truly doing re-engineering as defined by the official standards bodies around us. Only when we have this new information incorporated into the design do we redevelop the system in order to come out with a new set of requirements. These are not techniques that are known throughout the industry. They're starting to be taught sometimes in college and university, but most people discover them as opposed to are taught that they exist. Think how much more efficient the world would be if everybody understood there are well-defined approaches and techniques to this process. Let's take another component here as well, which is the word hype. So whether you're a CIO or a CDO, you're going to feel some pressure to purchase things because they're new and cool. And vendors are very, very good at selling. Typically involves the golf course and nothing in the way of requirements for the actual organization. But it's important for everybody from this point on out to understand what we call the hype cycle. Now, I'm introducing Lady Augusta Ada King, who we consider the founder of the data industry, which means we're only about 250 years old instead of thousands of years old as the accounting industry is. One of the other many things that she did that she wrote, when considering any new subject, there is frequently a tendency to first overrate what we find to be already interesting or remarkable, and secondly, by a natural reaction, to undervalue the true state of the case. Well done, Lady Augusta Ada King. She actually gave something to Gartner, who refused to claim credit for it here, but they put it out in slightly different, more technical language. They say there's some sort of technology trigger that leads to the peak of inflated expectations, and then almost immediately to the trial of disillusionment, up the slope of enlightenment, where we finally figure out what we're doing much time after the original technology was introduced. If you're not familiar with that, become so, because Gartner and others provide very detailed assessments of this. This is as of July of 2021, last summer, about a year ago. Data fabrics were about the crash, top of the roller coaster, you're getting ready for a ride, right? Blockchain, on the other hand, looks like it's fallen as far as it's going to go practically, and maybe a little further and start coming back. Data integration tools look like they're getting good at the process. Virtualization, very mature. And yeah, we're going to come back and talk about cloud in just a bit. Notice they're at the top of the peak of inflated expectations as well. One other piece of information you can get from this chart as well, you can see that the teal colored dots are 2 to 5 years away from the plateau in this case, and that's the of optimization, and the others are darker still, are moving even slower. So you get some sense of velocity around this as well. Now, the idea of what is data management is something we have to pay attention to, and luckily have formalized through the effort of a great deal of volunteers at DAMA International, where I'm privileged to be the president right at the moment. Without this guidance starting in 2009, you were trying to put this together on your own, essentially, with some good articles and things. But it's much easier to look at from a body of knowledge perspective around this. And notice we don't specifically make tools, but we do call out a series of tools. This is just the reference from the guide in here and where these things occur. And we're going to talk about just a couple of them here because we only have an hour to go through this stuff today. So we're going to do cloud, we'll do case tools, a little bit on ETL, some data quality, and then we'll spend a majority of time on data profiling. Again, another Gartner assumption here is that 3/4 of all databases will be cloud starting next year. Now, whether Gartner is correct or not is another sense, but some people take the fact that Gartner makes these predictions as a way to influence the market as well. No problem. No, but we'll be able to find out next year. In fact, tune into this very webinar and we'll try to update the information on this. Let's talk about clouds as a technology, though, for just a little bit. Most people, first of all, get very excited about it, and in fact, disappointed if you're not considering cloud. Let's be very clear. Cloud has tremendous advantages, but money is not one of them. If you think you're going to save money by going to the cloud, you will be sorely disappointed. The key is to be able to manage cloud in a way that these linear expansions of scale that don't permit for any economies of scale to get into this. So the way most companies approach the process of cloud adoption is something we call forklifting. They take everything that they've got and they move it into the cloud, but there's problems with that. Mainly, there's no basis for decisions being made whether to include or exclude something. It's all in there. They don't include the concept of architectural and engineering concepts, with particularly the ideas around sharing. There's no idea that these concepts are even missing from the process. And remember, 80% of your data shouldn't be in there anyway around this. So a better way to think about cloud adoption is instead to think of the opportunity of transforming to the cloud as a real transformation opportunity. And I say that data in the cloud has 3 attributes that data outside of the cloud does not have. Data inside the cloud should be cleaner. It should be more shareable by definition. And by virtue of the first 2, it should be less in volume than data outside the cloud. In fact, Gartner's so convinced of data around these concepts that they say there are really only going to be 3 choices in cloud, and they'll not be based on anything that Google, Azure, or Amazon does. It'll be based on the type of data that you're attempting to get to in order to look at this. So clouds will become ubiquitous in the near future, and anything that you want in terms of data will be your obvious selection of cloud. That's not to say that you can't do it the other way, but if you're just doing it for the sake of being difficult, it doesn't seem to make a lot of sense. Another tool, unfortunately, that is not taught is the concept of case systems. They're mentioned in some of the textbooks at the undergraduate level, but if you're not familiar with it, it's a set of software-aided computer-aided software engineering tools or systems engineering tools, depending on how you define it, that can help you with the process. In fact, there's some wonderful ones. I've been working with Visible Systems Corporation for many years, and they have the idea of incorporating process and particularly motivation or planning statements into the case tool such that you can trace the requirements all the way through to design artifacts. It's a wonderful set of technologies I've been using for years, was introduced by my mentor Clive Finkelstein in these. Again, this can keep track of whether some components are in various parts of this, whether you're going to print it out for the entire model or just parts of the model. A very nice way of structuring this, even down to including XML-based support around these types of concepts. And the whole set of case tools is that they have a lot of different ones. So you shouldn't just go buy one willy-nilly, although again, there are some very good ones out there on the market and 2 main contenders in the area as well. But here's a map that just shows the various flavors of case tools. So the idea is, where are you having trouble in your environment? And therefore, how can we select the right case tool to apply into that? There is a changing model of these case tools, and you'll see this, the idea that most had to be centered around one piece is now changing to where we can add metadata and other types of technologies to this on an ad hoc basis so that we can use them more in a utility fashion than this. And you'll see a variety of different interchange mechanisms that come about as well. The case tool market got so silly at one point that IBM thought they could devote a model to everything, and luckily they did provide this out into the public, so you can get some old back issues of the IBM Systems Journal to look at this. But this is, of course, overkill and completely unjustifiable from an investment perspective. Very, very difficult to say that you would have perfect information on everything, although it would certainly make maintenance a lot easier around that. In most of these techniques, it's actually quite easy to do your own version at first. And I say that because if you're going to look at dropping 7 figures on an integrated glossary of some sort, which is the most popular technology right at the moment, you're probably not able to have an articulate conversation with the vendor. And so it really is in your interest to build your own at first. And it's fairly easy in most instances here to build your own version of this, experiment with it, find out how well it solves the problem that you thought it would intend to solve the problem, and then decide whether making a significant investment in that or not is worthwhile. So the idea of a repository, you can use a spreadsheet. It's not ideal or optimal, but it has been run before. And if you take the spreadsheet and push it out through an HTML page such that everybody can get to the contents of the spreadsheet on an updated weekly basis through a web browser with a simple search function, that's some terrific functionality in this. In order to manage metadata, you have to manage metadata repository functionality, which means whatever you're doing for data management applies to metadata management as well. Again, moving quickly here, let's talk about the E spaces for a little bit. There's 3 flavors: extract, transform, and load, which is delivering data that's been pre-formatted to a new database or a data brick of sorts or something along those lines. Enterprise application integration, which is making the apps work better together as a family in there. And enterprise information, this is a information layer perhaps over top of your app layer. Again, these are just some of the things that you can use at an industrial strength in particular to try and help you with data preparation. More likely, you're going to become aware of quality issues, and it'll be such that somebody's giving you data that they know has some known quality problems on this. And so there's sort of 4 categories of cleansing activities, data quality activities: is analysis, cleansing, enhancement, and monitoring. Think of it as plan, do, check, act. Again, it follows the same process. And there's a fair idea of tool sets in here. Again, just very briefly, the idea that data comes in, it's not optimal. When you clean it and then group it, you can get to the arrangement that you'd like to get to around that. There's a preparation set of tools that can maybe help you with things like phone numbers. And I've got a link here to a very nice video by David Lotion that's certainly we're spending 8 minutes on in terms of taking a look at telephone numbers. You'll never look at them the same way again as well. There's identity matching resolution tools. This is absolutely critical, and even more so as you head further into the cloud and into data lake territory. The idea of identity matching becomes even more crucial. Enhancement tools so that you can add things like date and time stamps or geographic information, or merge this with other things. Again, using, of course, our social security number. No, he didn't say that. Again, using social security number is illegal, remember? But that's, of course, what everybody tries to do. Again, enhancing the data that comes out, reporting on it just so that you can get a general sense for what's going on. You'll see some examples of that when we get to the more advanced section of this as well. Using portals as a tool. I love the concept of data branding, and I've worked through that with a number of organizations. In fact, I'm reading a book about Nokia right now, and I see the results of something we did at Lucent Technologies back in the day that's actually made it all the way through to Nokia. So that was kind of an interesting round circle. But the idea of branded data, data that is of good quality, or at least of known quality, as opposed to data that is of unknown quality. There's all sorts of things that you can put in place. And finally here, where we're going to spend a fair amount of time, is on profiling. Now, I say profiling tools. Everything I'm going to show you in this can be duplicated with a good SQL programmer on this. So do not think of this at all as I have to go buy something. In fact, what I'm going to show you, you cannot buy because it's out of business, but various vendors have it in various components as well. So when you're coming to a new environment, whether you're a brand new data scientist or a new data leader taking over in another organization, you don't know what's in it. And you poke around a little bit and get sort of a data inventory type where we've got some of this and some of this. And this is just one example from one client that we were working with over the years. Again, then grouped perhaps like different chunks of it that go into here. Okay, there's great. Let's actually look at some numbers though. Oh, here we go. Wow, what have we got? Wow, 13,000 attributes, 6,600 of them unique. Okay, that's a bunch. Oh, wait, here's another system where we've got over almost 17,000 elements here, and another one with 9,000. Now, I can tell you, by the way, the first one was PeopleSoft. The second one is homegrown type of things. And the third one was an Oracle financials component in there, just as examples that were there. Well, when you're faced with an environment like this and you have that's about it in terms of the information that you have. Beyond the size of data, there are very few actual measures that you can use to compare across all types of data in there. And so it's a very interesting challenge. Needs a lot more research on this. But where we've done the best was from a PhD named Dina Bitton that used some research money from the Defense Department to develop this set of algorithms called data profiling, or sometimes called data discovery or data analysis. And the challenge to her was, can you speed up software technology analysis by a factor of 10? And the answer turned out to be yes. The key to this turns out the bottleneck in the process is generally our subject matter experts that we need to have in this. We call them SMEs, and we need to find out what's going on. In the old way, you'll see how it is. Not quite as complex as it used to be. It's easier, not easy in this, but we can pre-assign these pieces and most importantly, semi-automate the process. The word semi is critical because many people think it should be all automated and it's very difficult to do. I mentioned the way we used to do it in the past. I did this for years for the Defense Department, where you walk into a room, you set down a beamer or a projector on the table and you say, tell me about your business. And there's nothing more scary than this fear of a blank screen. No, your screens didn't go blank. I did that, but it's an awful sort of a process. The new way of doing this, as I mentioned before, is semi-automated, but we can focus it in a well-established process that we're going to walk through at the general terms. It gives you metadata in a repository independent format, and you'll see as we're going through this, we are doing quality analysis at the same time. It's a wonderful, very, very powerful technique. It's repeatable. It gives you current information, not just current as of a certain place, but as your data is currently. And it gives you the ability to verify and accurately see what's going on. So these next few screenshots are from a thing called a Migration Architect. Again, I mentioned before, it does not exist anymore, but these capabilities are available in a number of different tools from the vendor community here. So here we're doing, first of all, what's called column profiling. If you look on the left-hand side under the Sybase piece that we have here. Let me see if I can actually, go back. I think I can put my cursor over here. Well, maybe not. Anyway, it shows you on the left-hand side there that we're looking at the customer ordering. If you look under the columns section, you'll see customer order goes down a ways, and then it goes to employee info, which is the next table. And in the customer order table, the attributes are order date, order number, order date, ship date, PO number, et cetera, et cetera. And what you're seeing here is a bunch of information that is gained from looking at a sample of the data. Generally a sample of about 16,000 attributes randomly collected, and you have to know a little bit about the data organization in order to do this. Will tell you a lot of information about this. On this screen, I'm just showing you the number of distinct records in the first row of customer order, which is order number. There are 197 distinct ones out of 1,573 records, and you can see the ratio is very low in that case. So this again gives you some factual information about a subset of the data. If you do further drill down into it, you'll see that shipping date, for example, is supposed to be a date time function that it infers from the metadata. But in this case, it is also telling you that it's incompatible because you're using this perhaps as a planning for an ETL process or a database migration. And so you have to look as well and see whether these compatibilities are going to be problematic. And you don't want to load the database up incorrectly a bunch of times. You want to get it right the first time in order to do this. Again, you can look at the documented types of information. It's null, is not null is permitted. So it says, but it says, you have nulls in there, so therefore it's a problem. And again, it flags it as incompatible. Lots of things that the computer can do. Here's another one for this was a telephone company, and there was a home telephone number, and they had multiple versions of the home company. And notice here, when we clicked on row 31, you'll see that it pops up at the bottom and shows us there are 3 instances of 602.789.7200 in order to do that. And if you've got a master data situation and you're trying to figure out which one gets the bills, how do you know? So it could be a problem there. Again, I'll show you a more comprehensive view of this, but let's take an approach. First of all, for example, a question might be, why is pay code an asterisk? What is the value of that? Well, if I click on that information, I can find the actual distribution of it. And you can see that it occurs in 11.49% of the time. And I can double click there and find out a little bit further that asterisks, oh yeah, somebody said asterisk in that column meant that the pay code was from the United Kingdom. And sure enough, the information comes up to see that as well. So this is how you can use these technologies to do an interaction. And I'm going to show you now a video of this. Again, video is a model, a little movie on this. If you're interested in these, let me know. I can happily share them with you, but I'll narrate it real quick. It's about 1.5 minutes, so I'm going to narrate quickly. And of course, that's why Shannon tapes all these, so you don't have to get all this on exactly the first order. So I'm going to click the first piece of this that I'm going to do is I'm going to import the metadata. I'm going to read it in from wherever I'm reading it, whether it's the header of the database record or whatever else. And I bring it in. Notice next part, I set up my search parameters for the sampling, bring in a value in order to do this. This is so old that we used to have to worry about processing time. We would set these things up on a Friday afternoon and hope it was done by Monday. That was, again, pre-cloud, but nevertheless, it is an analysis period. So here's the results of the analysis on the employee detail. Notice again, we have attributes, the documented data type, and what it infers the data type is by looking at it actually. So is there a variance between the inferred and the actual? We have documented and inferred minimum values, and then again, whether there's a flag on the play, we need that. We have documented and inferred maximum values. And again, we can look at see whether these are compatible depending on what I've set up for my target rules, whether I'm allowed to have nulls or not in this, and the number of distinct records. Each of these also is fully sortable, so you could do a lot of work in here, and you'll notice it actually supports some workflow characteristics. It's selected employee detail. We set it to the top. Let's take a look at what's going on here. It says it's compatible. Oh, look at this. There are different formats in the record. I know how to fix that. That's an easy problem to solve. Here's one for employee sex in here. Let's look at this. Oh, goodness. Look, zeros wasn't actually formed. We should have a problem with that as well. Employee address lines, well, it says the nulls are okay because sometimes you have none in it as well. These are all problems that you can use. And more importantly, you can work your way through each attribute of each table that you bring into the systems. Again, in 2 minutes, that was column profiling, how to introduce yourself around these pieces. So let's go to the next now. After we look down the values of every row in every column of the database, we can now look across the columns and see what changes when what else changes. I know that's very vague. Here are all the possibilities, the inferred dependencies up here on the left. And again, you can see that the determinant is customer name, a combination of customer name and order date, and the dependency is the shipping state. Well, it sets them all to true for starters, and then we have to go back and decide whether they are in fact real or not in order to look at those. The ones that are real, we can promote into a relationship in there to say there is an official business rule that needs to occur between these two categories. And you can notice differently here now on the right-hand side, number 2, order number and PO number. The order number determines the dependence purchase order, that's the word I was looking for, to pick up on that. So again, what you're looking here is down every combination of every row and every attribute and saying what's interesting about this. So here's our second little preview movie kind of thingy here. What we're looking at is the employee social security number. Remember, we're not supposed to use this, but of course this was back in the day in order to do this. And employee social security number dependent birthday. Yeah, no, we may want to think about that one a little bit. And you can notice it's found all of the possibilities. Our job as experts in data preparation is now to say what is the actual that we're trying to get to. Well, again, the dependencies are there, the determinants are there. Let's just take that and look at the various components that are there and say, let's just pick one, the employee job code in this case. So there's the employee job code. Gray, by the way, is a medium piece. Oh, look at this. G and F should be at 80/70s, and they're 1 and they're not. And so let's fix them. We figure out which one's the error, and then we can actually promote that determinant. Job code determines, in this case, current title. And we can actually make that a model, a rule in the model. Let's take a look at the conflicting data that's there. Oh, look, 8071 is either a sysanal or a systems analyst. By the way, this is the best argument ever for letting people define things off of pre-list pick lists in the case. You can see, again, lots and lots of little minor data quality errors that are in here are really problematic. And if you're going to do an analysis of these, you of course want to have all of this the same, much less if you're going to migrate it from one system to another. Again, we can add these to the model here. Notice they've now determined the effects. We push them all the way out to the model in there, and now notice that the pieces come out on the other side here. There we go. They are now locked into that, and we can now start to work our way through. So again, we have an ability, we've looked at all of these things and said, yep, employee ID is going to determine all the rest of these things in there. Let's add these to the model here as well. And in one swoop, we can add all of this information up to the model in order to find out. And again, notice it keeps track of what you've done so that you can keep the workflow going on it as well. Now, again, this is a very, very quick 2-minute overview of what happens, but we've looked down at each attribute, and that's the first column profiling. And we now know the characteristics of each attribute, the minimum and the max, whether it can be null, how often it represents the primary key on a percentage basis of what goes on. And now we've taken that same table and we've now compared every value change to every other value change and said there's some of those that are real and some of them that are not real. And we want to have those promoted into the environment so we can figure out exactly what we're attempting to do and how we're working with it in order to prepare the state. And the third stage of the process then is redundancy profiling. And this is the idea that the more data I read into this particular tool, the more I will remember it. You can, again, accomplish this yourself with your own set of programming tools. But let's go ahead and watch a little bit of what happens here. So first of all, we're looking at the overlap between SUP ID, which is supplier ID, and employee ID, and noticing that there are 16 distinct values between the two. Maybe a problem. Well, if I'm doing a fraud ID and I find out that a small percentage of my employees are actually vendors to my company and they're not registered as such, that 12% may or may not be a problem, depending on what I'm attempting to do. So as I mentioned, this is our third little video here. Again, that was looking at record in relationship one. We're looking at order records and the ship by ID attribute and comparing it to employee detail and the employee ID attribute in there. And notice there's a 39% overlap on those two. Well, when I find out that's the case, I can now go to my subject matter experts, find out, and show either the overlapping values or the non-overlapping values, or I can show them all, again, the different ways of configuring with the tool and doing the analysis work so that you can ask the right questions. And once we do find them out there, we can make them a synonym, and all of a sudden I am accomplishing integration across my enterprise by being able to find out in a semi-automated way how these records relate to each other. The more that you read into the tool, the more likely it is to notice that you've made these specific changes. Now, let's think about it. I've just gone over in the past 15 minutes a fairly detailed little component of this. It's a very generalizable approach to data preparation. It's a very good way of introducing yourself to a data set. And where we used to run into bottlenecks in the past was that nobody felt it was interesting enough to do. So you want this function, this capability in your organization housed within one special group. I typically like to make sure they are part of the data program so that everybody is on board, and think of them as like a fire station utility. When I have a data problem, I can bring these set of technologies to bear to the various problem. It's probably not a good idea for you to train all of the knowledge workers in your organization on this, but it probably is a good idea to make sure that all the data people in your organization know that these capabilities do exist and are available to you as a data specialist in this area. Let's compare now the 80-20 progress that I told you about. This was considered to be a very significant advance. When I was doing this for the Defense Department, and I worked for DoD for about 10 years, as a federal employee doing this, the idea was that you spent most of your time working with the subject matter experts in sessions during the week. We called it afternoon and morning sessions, and we worked that way. And that gave us only about 3 days of model preparation that we were able to do in most cases on this. And many of the Fridays were canceled just because it was, again, sort of a wearing process. The revised process with the result of semi-automated reverse engineering technologies allowed us to do much more offline and only bother the specialists a couple of times during the week in order to come up with this information. We also developed, as a result of this, how long it would take to do the data preparation on this. And it was case line of the system survey, and it was basically a component of the amount and the condition of the evidence that you had. So if you had the actual code that went in, that was terrific. Sometimes you did, sometimes you didn't. Sometimes the system was written in a programming language that might be obscure. One of the more obscure ones I worked with was the programming language MUMPS. And some of you in the healthcare facility may be familiar with that. It's a very interesting set of technologies in there. And if you have the ability to add automation to it, then the impact can be generally reduced down. These give you your project characteristics, and then you have to compare them against the way you've done this work in the past in order to come up with your estimate. The idea is not that you're going to come up with a right number, but if you start doing this early, you will be able to start getting better at estimating this by understanding the components that go into how long does it take to do preparation. One of the more fun examples of this was that we found a bunch of empty data in data warehouse tables, which meant they could postpone a hardware infrastructure upgrade, which was a tremendous value to them at the time, made a good, strong case for normalization. And to their credit, they were really proud of the fact that the board of directors for the warehouse actually gave the team a standing ovation around that. They were also able to preserve multi-million-dollar pre-sort discounts for the shipping facilities, again, processing all sorts of other components that get along the way. So as we get into the takeaways around this, let's just start off with a very straightforward statement that we're all guaranteed employment for the rest of our life. So says Peter, because the growth between the growth in data and the growth of our ability to provide analyst support for this continues to increase in spite of everything that we have done in order to make this and speed up the process. Remember, everybody knows it takes 80% of the data analyst's time to prep the data, and yet we still have this incredible growing gap. It's a problem. One of the biggest fallacies we use is a binary solutions fallacy, and that is the idea that we have to either automate something or not. So I'm going to give you just 2 minutes or so on diminishing returns, because that's clearly where you should invest your resources. If you're looking at a 4-week project and you determine, and let's just pretend for the sake of argument that it costs $1,000 a week to do this activity, regardless of what it is. If I've gone to week 4 and I've solved 55% of the problem, that might be a very useful set of numbers in order to figure out what was there. In the process, of course, we can learn that we can ignore a small percentage of the data in this case, and that the problem space size was generally shrinking as it went through the overall effort. Working another 10 weeks, we've now gotten to the point where we have only 9% of the problem space still remaining to be solved. And somebody could look at this and say, I've spent $14,000 because it's a relatively number, 1,000 times 14 weeks. And is it worth more money to try and gain some additional? And somebody said it would be worth $10,000 more for me to get this one more piece of data, one obscure piece of data that they were afraid they wouldn't be able to pick up on their own on this. And so they were able to achieve that in $5,000. That seems like a win. Again, these are the way we talk about it. We also clearly showed that 1 in 5 pieces of data that they had was just absolute rubbish, and that we were able to solve automatically 70% of the problem, which meant that instead of having to solve this much of the problem before, by the way, this is a real life example with the Defense Logistics Agency, the problem was only 150,000 instead of 2 million. Now, the reason that's important on this is because the original projections for how this was going to take was a case of there were 2 million national stock numbers, NSNs or SKUs, as you know them in the private sector, and we just put a measure on it, 5 minutes to cleanse each one, which meant we needed 10 million minutes, and we were working 48 days a week times 5 days a year, 7.5 hours a day, 450 minutes a day, 108,000 work minutes in a year, which, and the 10,000 divided between the two gave us 93 rounded up person years required in order to cleanse this data. And at $60,000 a year, which was the number we were told to use in those days, the original plan would have ended up costing 93 person years and $5.5 million for the DLA for this particular exercise. Because we were able to submit a revised process in here and only needed to cleanse 150,000, the total time in minutes declined precipitously from there. And instead of the minutes needed rounding up there, we ended up with just 7 person years required to do that smaller 150,000 pile high piece of this at a cost of $420,000, saving the government $5 million. Now, that's just the start of this. The other part of this, I like to do a little social engineering as well. And those of you that are experienced in the area know that there's no way any technology can help you cleanse the average data item in 5 minutes. So if we double this, we're at $11 million. And if we go to the real number, which is about an hour per item that we have to look at on this, we can see the number is approaching tens of millions of dollars in order to do this. So the idea is finding the right place of diminishing returns with respect to your tools. Don't expect or try to achieve perfection out of them, but find something that works. There's nobody in the government that isn't happy to save $5 million around this process in order to help make your data migration process, your data preparation process much faster, better, cheaper, and less risky. So takeaways on this: we spend too much time focusing on technologies as the solution. The key for your solution is to understand it as a process of systems, people, process, and technologies. Three-legged stools that are interdependent. And the better you understand your needs, the better you'll be able to use and evaluate the tool in order to do this. And the value that is there can be gained by the general approach of introducing yourself to a data set under any set of circumstances with a number of different technologies in order to do this. That the data volume is still increasing, and so anything we do in this area is going to help organizations measurably improve their productivities around all of these. And the idea is, let's find existing technologies. Let's not depend on things. So use things like the vendor communities will typically provide user groups and forums and places where you're able to go in and share information and knowledge around these topics in order to come up with the types of things that it makes sense for an organization to actually invest in and use. So the idea here is to really take a step back, and instead of looking at a tool to provide a specific function, find out what is the general class of functions that you use and look at the tool as a component of your data management technology architecture and figure out what parts of your data preparation process that are largely unknown at the moment could benefit from some improvement. When you use those improvements and apply to them, you can try yourself to put in place some technologies that will give you an idea of questions that you can now use to interact with the vendor community and talk to them in the way they'd like to. The vendor community is super educated and super happy to talk to you and measurably excited when they find customers that have really good idea of what they're attempting to do with their tools and are able to very quickly, very easily come up with that information in order to do this. We're getting at the top of the hour here, so I'll just remind you, we've got another set of these coming up. We're going to look at conceptual versus logical versus physical data. In the next one here should be an interesting discussion. Then we'll do importance of metadata and move our way on up the chain on this. And we're back at the top of the hour. We're going to welcome Gary back to the group and see what questions you guys can have for us around all of these topics.
I love it, Peter. Thank you so much for another fantastic presentation. If you have questions for Peter or for Gary, feel free to submit them in the Q&A portion of your screen. And just to answer the most commonly asked questions, just a reminder, I will send a follow-up email by end of day Thursday for this webinar with links to the slides and links to the recording. No questions coming in yet, but there's been a lot of debate on and interest
the chat
in
topics. Well, let me ask Gary a question. So
mostly,
Gary, can I?
Yeah, go ahead.
Gary, can I put you on the spot?
Absolutely. That's why I'm here.
Yeah, exactly. So we were talking before about the way in which people become aware of the various technologies and the tool set that you sell. How did you yourself become aware of it?
Largely through my long tenure at Quest. This is my 22nd year with Quest Software, specializing mostly in the information management products. However, I got a taste of that all the way back in my first 10 years of the career. So I was a systems analyst, designing systems for a couple of large mainframe shops. And we used a variety of tools, which I still see is the common practice today for most of our customers. Literally, some of our customers use hundreds and hundreds of different tools to manage their data and the data management lifecycle. So things from, case tools to data modeling tools to data governance tools that perform things like data lineage and metadata and master data management. The list goes on and on. You're not going to find one tool that does everything. So short answer, yeah, partly of my employment in the first 10 years as a systems analyst, and then Quest Software has done an amazing job of creating some products in-house and also acquiring products that dovetail very nicely to their vision in terms of information systems management.
Exactly. Over the years, it's a management team that has become known for knowing the space, knowing what niches to fill. The reason I brought this up for everybody as a topic, though, is that and I'm going to put my academic hat on here and say, we have failed you in the academic community. We don't even tell you that these technologies are useful. I remember the first time I ran into Toad, I was doing something at a commercial bank in New York City and had to look inside of something, and somebody said, well, why don't you just use Toad? And I thought they were kidding. In those days, Toad was considered a strange name. We've gone way beyond that particular piece, but I learned how to use that technology very, very well. And the fact that Quest decided to pick it up and make it part of their portfolio is representative of the kind of thinking that goes on. But it is terrible, in my opinion, that the university community doesn't educate people who are smart, who said, oh I'm willing to bet, Gary, that many people have invented Toad on their own and then discovered that it already existed in there. And it's just such a useful utility. And that's, one part, as you said, of a portfolio of these kinds of technologies in there. But it just is, it's a shame that we haven't done better in the academic community of saying these things are important. When you're out there, your productivity is the one thing management can really complain about and really benefit as you start to do this. These tools are all about making you more productive as a data professional.
Yeah, as a quick follow-up to that, I appreciate your comments there. I used to teach part-time as an associate faculty member on the math side, mathematical sciences at Purdue University. But I think part of the problem there, Peter, is that technology changes so rapidly that it's really, really hard for folks to keep up, even folks that are in the profession, to keep up with the proliferation of tools. So that's one problem. And
certainly is the case. As an older faculty myself, I can tell you that I can barely keep my Amazon knowledge current, much less anything else that needs to go on in there. And again, it's wonderful stuff. But we should teach them that these tools exist, and that we may not know exactly what shape it is or size or whatever. We need to let these young people know that there are better ways. It makes us look dumb. This is where we get the comment, "Okay, boomer," although you may not be old enough for that particular comment, Gary, but people are like, come on, this is old stuff. You guys don't really use COBOL anymore. Well, you know what? Most of the fraud that was done in the PPP program was because people didn't understand COBOL really well.
Yeah, agreed.
Oh, sorry, Gary, I didn't mean to interrupt you.
No, I was just agreeing.
Well, so, speaking of tools, the question came in, for what data profiling tools do you recommend, Gary, from Quest?
So there's a couple of names I want I saw that question, so thank you for calling it out. First of all, you need to look at a product called Toad Data Point. That is a client-based product that sits on your Windows workstation, but the professional version of that product does have a data profiling engine, and that engine does supply or present to you statistics on what we see in terms of the values in each of the columns that you're looking at, whether it's a table or maybe you've created a query and we're looking at the data from that query. We can analyze the quality of the data there, the distribution of the data. We can give you statistics on what we're seeing, the top values, bottom values, etc. So that is a product that would be well worth your time to take a look at. That's not the only thing it has. It does have a nice transformation and cleanse engine to it. It can do cross-platform migration, cross-platform queries, if you will, to blend different sources together, a number of different capabilities that a data analyst, I can guarantee you, would love. The other side of the coin there is Irwin has some capabilities that can do dependency analysis and data governance in terms of data lineage and intelligent data glossaries and things like that. So that's much more of an enterprise level solution rather than a Toad Data Point, which is a quick client-based solution. But those two product solutions, I would definitely take a look at it in terms of Quest.
Gary, if I can, I'll add on to that. I actually have in my hand a CD with Irwin 3.5.2 on it. that I carried around with me as a consultant in order to work on various projects. I was fully licensed to me and I could do it. And I would walk into a place and people would say, well, I don't know how to do this. I don't know what the data actually looks like. Hook it up to it, hook up the reverse engineering engine. It spits out spits out an accurate physical as is model that you can take a look at. And people would just look at me like I was a unicorn. It's like, nope, it's
A
just
hero.
good software.
Yep.
Absolutely.
Now,
Good stuff.
yeah, no, I'll just say, because so data modeling is one small part of the Irwin stack of solutions, but your 3.5 is not current. I think we're on version 12.x, so definitely check it out. There's a lot of things that we've added to the product since your 3.x version.
You probably haven't put it out on a CD in a long time either.
Well, yeah,
CD
most
guys,
people,
that's a round
yeah.
thing we used to stick in a player to make music out of before streaming.
Some people thought it was a cup.
Yes, a cup. What do they call it? Dish. Oh gosh, now we're both splicing on the coaster. There we go. That's the word we were looking for. Coaster.
Yep.
Yeah, absolutely. All right. Well, Shannon, any questions around?
Not currently. There was a question about the writing the name of the tool. So it's Toad Data Point. I'll put that in the chat. I just put another link in the chat as well. And Gary put one in there earlier. So you can check those out. And we'll be sure to include that in the follow-up email as well. But otherwise, everyone's pretty quiet. Any additional questions y'all have?
Usually quiet group. Maybe we lost them.
No, I think they're pondering. Again, a lot of the discussion has been about tools, so it's very interesting.
Well, you can see how hard, Gary, how do you advise organizations to keep balanced in their approach to tool? You already mentioned before, you think it should be a portfolio of, learn a bunch of different capabilities and figure out how to use them. I assume you agree with my making that a centralized part of the group would be better than trying to disperse it and coordinate it across the organization.
Well, it's an interesting question, Peter, because I have quite a bit of tenure. I have worked 10 years in IT, and just even in that 10 years and then beyond those years, and I'm not working in IT as an IT professional any longer, but I speak to thousands of customers in the course of my tenure at Quest, literally. And it's interesting to see the cycle. So at issue is sometimes IT is centralized. They go in cycles or waves, right? An organization will think, oh, I don't want to centralize my IT organization. There's too much backlog. Our business units need to be autonomous, so we're going to have fringe IT departments. And then what happens when you decentralize an IT organization, things like master data management fall by the wayside. The tools architect falls by the wayside. The one person that says this is, I'm going to standardize on a set of tools. But when things get decentralized, now you've got lots of business units doing their own thing. It gets very, very difficult to manage that way. So that's what we're seeing right now is a lot of corporations, a lot of organizations that we talk to find it very, very difficult to standardize on specific tool sets. So once they get knowledge of a tool set that will really work for their organization, they're willing to buy it, they have the budget for it. But sometimes it's hard for someone in the organization to say, hey, I'm going to step up and say, we need to standardize on this tool.
And they truly don't know that they don't know is what I find out. And this is the frustrating part about it, because if we'd at least make them aware as part of a standard IT curriculum that there are ways of looking for assistance out there, as any good programmer would look at a problem of that type. And I'm sure you designed your set of tools when you were 10 years in IT in order to come up with a solution to a problem that was in front of you, right?
Absolutely.
It's just a standard part of the way we're wired as IT professionals in order to do that. And yet, the students should come out of college and university and say, all right, who knows about tools? Where can I go to find out? And you guys actually support the whole concept of forums and communities and have annual user conventions and everything else that supports your community, right?
We do. Yeah. Toad World being one of those, that was the first link I put up there. But you're right. I mean, at the very least, it would be nice, even if you don't touch the product or use them in the classroom, it would be nice to have a nice summary to say, hey, these are the types of tools that are out there from these vendors. Go take a look at them, on your own time. Or even better, as part of the classroom curriculum. But sometimes that's difficult to do because the tool sets do change and the technology changes.
It is difficult for the university professors to keep up with it, absolutely. And also, again, IT within the university doesn't really want a server set up so that it can have open access.
Yep.
It's just not the
Agreed.
best recommended risk posture under all of these. But we do have an awareness issue that I think, and it carries on to DAMA as well. When we survey our members, we find that they, like you, Gary, spend about 10 years in IT. And we're constantly seeing that at least if data was better, things would be easier. Nobody's claiming perfect, nobody's claiming 100%. But if we could do some things better with the data, it might make things better organizationally. And yet, by the time you say that 3 times, you then become the data person in the organization, and you're expected to now start providing answers for this. You look around, you find Quest website, you find Data International website, and say, there's my peeps. I can join this community. It's wonderful to be able to talk to other people that are using the same tools and approaching the same kinds of problems, and perhaps have run into a situation like this before and can leapfrog on this. This community is very, very willing to share. And really, even the banks have been ruled to be non-collusive if they are competing at the metadata level as opposed to at the data level around that.
Yeah, I appreciate those comments as well. You have no idea how germane or relevant this particular topic is on data preparation. When I talk to customers, the data analysts, and there's different titles for these men and women, they are spending a lot of time trying to bridge the gap between raw data and presenting it to basically the end user or the leadership team so that people can make decisions and consume that data appropriately. So a lot of work that needs to be done there.
And you mentioned the cyclic nature of it too. I'm sorry, Shannon.
Yeah, go ahead.
If you go on LinkedIn, the number of data engineers and data scientists is kind of like been a horse race the past couple of years. One will pull ahead of the other for a little while, and then the other will catch up and pass it, and then go back and forth. It's the same thing you were seeing as the cycles approaching that as well. It's just very, very difficult. People are not even sure what those terms mean. I've got a group, for example, here in Richmond that says data engineering is all about mechanized transfer, not really focused on analysis components as well, but more in terms of optimization and things. Again, yeah. Perfectly good topic, but we've got a ways to go as an immature discipline, and we need to work our way out of it.
Yep.
Peter, I mean, as you say, it's cyclical, we see it all the time. And do you think currently, in the talk of technology and how quickly technology changes, technology is what's driving the current demand for data prep? I mean, we've heard so many companies trying to stand up machine learning and just fallen down because they didn't have any data prep, and it's driving not just data prep, but new job titles for data modelers and things like that.
Absolutely.
Is that what you're saying?
It's ironic, Shannon, that the ML community in particular could benefit the most from the things we're talking about here. So in the literacy book, I made a big point of saying that we thought that the year 2020 was going to be the year that ML ran out of data. And the reason why that statement is still true today is because machine learning has gotten to the point where they are developing what are called learning algorithms. And the algorithm says, if I've got the right set of data, I can train this algorithm to learn the things I want it to learn and thus outperform humans, both in terms of faster, better, cheaper, and with less risk around all of that. And that's a great thought, but nobody in the ML community understands where to get that data from. And the data that you need is actually the data that we've been talking about for the past hour. It is the data in your legacy systems that encapsulates the legacy business rules, the understanding of the various quality controls that have been applied at various stages, all sorts of hidden things. Gary, you've never run into stored procedure hell, have you?
That chuckle means a big yes.
Absolutely, absolutely. And that for those of you that aren't aware, there's a way of burying a rule down in a data set that only fires when the attribute is hit. And so the attribute may get hit and then send off something else that you had no idea was going on because it doesn't show up in your scans. Nobody's managing it formally. There's just somebody somewhere that knows what to do around those topics. Yeah, it's a huge issue. And so the ML community really needs to understand the kinds of things that these technologies can help to do and set up, because that's how you're going to create the data set, the training algorithms that you need to have in order to truly realize the promise of what's out there in ML. At the moment. And I don't see interest. I don't see people looking at it. And yet every time we apply this in that context, people just make light, what's the word? Warp speed. There we go. That's the word I was looking for. Back to my Star Trek days of being able to make leaps forward in that. Gary, do you guys get into ML at all? I know you had the profiling engine. Does it work in that context?
We do not, but I am actually, in my own way, I'm trying to personally push the company to look at that. And I appreciate your comments, by the way, not to deflect your question. We are looking at ML. It's not there yet in our products, just to be honest. Maybe a little bit on the Irwin side, but going back to what you were saying, two things struck me. Number one, ML is great for certain things. It certainly seems that machine learning is really good at taking a look at the trying to intelligence-ize, I guess I could say it that way, the consumerization of the data, but the data prep, you're not going to find a lot of ML, and I'm not an expert at this, right? But we need to look at two sides if we're going to be applying ML. One is for data prep, and then the other is also for data consumerization, so decisions can be made, etc. And it seems like it's very much weighted on the consumerization side where data is concerned, and not so much on the prep side. So we are certainly taking a look at that. It's going to be a long road, or nothing's going to be here in the next year in terms of us as a vendor. But we do see some AI and some ML being very, very applicable to what we do. And to that end, I was going to ask you one last question from my part. What are you seeing in terms of trends for data ops? There's the concept of DevOps on the operations side, but how about data ops?
Wayne Eckerson, if you're not familiar with him, everybody else, has a great webinar where he takes data ops and walks through it in about an hour. It's a terrific piece. The short component of it is, if you haven't read the Unicorn Project or some of the other very fundamental texts in this area and are not looking at them as an opportunity in your organization, you are missing a very important set of technologies. That said, the data ops component is really about optimizing an existing process. And if you don't understand your existing process, you will have no ability to go straight to optimization. So there is a learning curve of getting to there, and data ops is an aspirational rather than an actual implementation in most organizations today. Also, it's at the very peak of that vendor hype curve that's up there and potentially available to fall through on it. But we've learned some things over the years with Agile. We've learned things from DevOps, and these are all wonderful pieces of data that can help to inform our process. So does it make sense to take an existing procedure that may be less standardized and look at automating what we can and documenting every aspect of it such that somebody can come revisit in a couple of years and understand what our assumptions were and why? My favorite example around all that is an interesting one where we had a set of data that was on an old disk or an old set of disks, and we had to re-engineer it into the new one. And it had on the old disks the A's through the G's on one disk, and the H's through the K's on another disk, and the L's through the O's. And you say, why was that? Well, the old days, the disk could only hold 100 megabits. And so that was what you had to do to chop the data up. Is there any sense at all in replicating that design? Oh, no. And yet I've got actual documented examples of that kind of bad thinking going into the development of QuickBooks Online. Not to pick on anybody in particular, but I happen to know that a little bit about that one, both as a user and as a critique of their development methods that they use to not fully understand the problem around that. I can tell you this one, Gary, you'll get the same chuckle out of it. There is a concept in QuickBooks Server Edition of a transaction reference, right? As you might imagine, every transaction is going to have a complete unique number so that you can look it up, because after all, QuickBooks Online is a very integrated, sophisticated database, right? that concept is not available to you online because it wasn't visible as a requirement. And the people who were told to document the requirements didn't see it and therefore didn't think it needed to be in the online version, and consequently have crippled the online version with the inability to do audits in that same fashion. What an insane situation. Sorry, I didn't mean to get on a rant on that one, but I've actually been on the bad user side of that one. QuickBooks, if you're listening, it needs fixing.
Yeah, I guess it just draws attention to the fact that feasibility study and design is very important.
So Gary, before we drop here, do you agree with this 80-20 rule that we've got up on the screen?
I definitely do. And I speak to, I think most of my data analyst constituents or customers would certainly agree with this. Someone else's, 80-20 rule may vary. It might be 60-40, but it's definitely weighted on the data prep side.
And everybody knows this, right?
I think if you don't know it, you probably live it.
And yet we don't start off conversations with doing this. So if it's going to take you 6 weeks to analyze this data, that means sorry, I better do some easier math for you. It's going to take you 20 weeks to analyze the data. It's going to take you 100 weeks to get through the whole process, right?
Yeah.
That's just kind of obvious math there, and yet it's not well understood when people are planning these projects. And of course, when you see yourself faced with a situation, is exactly why you turn to a company like Quest or any of the other wonderful vendors that are out there and say, what have you got that can help me speed that process up? And that's the kind of good conversation that you would love to have with customers.
Yeah.
All right, Shannon. Well, we managed to keep people online. I guess that if you don't have any questions, guys, we'll call it a day here a little bit early. But Gary, thank you so much for spending time with us today. It's been a joy to work with you on this.
Certainly my pleasure, and I really appreciate your presentation. A lot of good spots there that really resonate with me, and I know also with my customers as well. So thank you for presenting that.
And Shannon?
Yeah, thank you both.
Always.
Yeah, and just again, reminder to all the attendees, I will send a follow-up email by end of day Thursday with links to the slides and links to the recording. There's questions about the data ops webinar you mentioned, Peter. I'll get a link to that as well if you'll send that to me. So thank you all, and I hope you all have a great day.
Thanks for joining us, everybody. Thank you, Gary.
Thank you.
Thank you, Shannon.
Thank you, Peter. Thank you, Shannon. Thanks all.
Thank you.